Lift a book off the table. Which object stores the energy you just spent? The book or the earth? The honest answer is neither, and the reason is Newton's third law. The energy is real. A conservative force will hand back every bit. Yet right now, it is nowhere in sight. Something must be keeping the books. In this video, we build that bookkeeping quantity, potential energy, and find it belongs to no single object. It belongs to the pair. Take two objects, masses m1 and m2, alone in a closed system. No external force does work on them, so the total energy inside cannot change. They interact through a single conservative internal force. The subscripts carry the whole derivation, so fix the convention now. F21 means the force on object 1 due to object 2. The first index names the source, the second names the receiver. Likewise, F12 is the force on object 2 due to object 1. Newton's third law links the pair F21 equals negative F12. Equal magnitude, opposite direction. Whatever object 2 does to object 1 does back. Now the geometry. Pick an origin and draw the position vector r1 from the origin to object 1 and r2 from the origin to object 2. Define the relative position of object 1 with respect to object 2. r21 equals r1 minus r2. As a vector, it stretches from object 2 to object 1. During the interaction, object 1 shifts by a small displacement dr1, and object 2 by dr2. Subtracting, the relative position changes by dr21, which equals dr1 minus dr2. This relative displacement is about to absorb the entire problem. Energy next. By the work energy theorem, each object's change in kinetic energy equals the work done on it. Let the system evolve from an initial state A to a final state B. For object 1, delta K1 is the integral from A to B of F21 dotted with dr1. For object 2, delta K2 is the integral of F12 dotted with dr2. Adding them, the system's change in kinetic energy is the sum of the two work integrals, the total work W sub c done by the conservative force. One caution. The labels A and B name states of the system, not paths through space. Now Newton's third law does its work. Replace F12 with negative F21 in the second integral. The sum becomes the integral of F21 dotted with dr1 minus the integral of F21 dotted with dr2. The same force now appears in both integrals, dotted into two different displacements. The dot product is linear, so the two integrals merge into one. The integral of F21 dotted with the difference, dr1 minus dr2. And that difference is exactly the relative displacement. The two-body work has collapsed to a single integral. W sub c equals the integral from A to B of F21 dotted with dr21. Swapping the two objects' roles flips both the force and the displacement, so the two minus signs cancel, and the integral written with F12 and dr12 gives the same value. The work depends only on how the separation changes. That single integral earns a name. Define the change in the system's internal potential energy, delta U, as the negative of the work done by the conservative force during the relative displacement from state A to state B. Delta U equals negative W sub c, which equals the negative of the integral of F21 dotted with dr21. Only for a conservative force is the integral path independent, so only then does delta U depend on the two states alone. W sub c also equals the system's change in kinetic energy, so delta U equals negative delta K. Whatever kinetic energy the system loses is potential energy gains exactly. Their sum is 0. And since the work is an integral over the relative displacement, this energy belongs to the pair. No piece of it can be assigned to either object alone. Now restate the previous video's promise as bookkeeping. Send the system on any excursion that returns it to its starting configuration. The conservative force does zero work around that closed path, so delta K over the round trip is zero, and the delta U is zero too. The kinetic energy is completely recoverable, now a plain line of accounting. One more result falls out of the relative coordinates. Write Newton's second law for each object. The pair force is all that acts. Object 1's velocity changes at the rate F21 over m1, and object 2's at F12 over m2, that is negative F21 over m2. Subtract, and the relative velocity, object 1's velocity minus object 2's, changes at a rate of F21 times the quantity, 1 over m1 plus 1 over m2. Name that combination. Let mu equal m1 times m2 divided by the sum, m1 plus m2, the reduced mass. 1 over mu is exactly that bracket. So the relative motion obeys F21 equals mu times the rate of change of the relative velocity. Two bodies collapsed into one effective particle of mass mu. Fit this into the work integral. The relative displacement advances at the relative velocity, so the integrand becomes the exact time derivative of 1/2 mu times the relative speed squared. Integrating leaves the endpoint difference. The work equals 1/2 mu times the relative speed squared in state B minus the relative speed squared in state A. And that is the system's change in kinetic energy. Real systems rarely contain a single interaction. Suppose several conservative internal forces act, each between its own pair of objects. Take any one of them. Its change in potential energy is the negative of the work that force does. The integral from state A to state B of that force dotted with its own relative displacement. Work is additive. The total conservative work is the sum of the individual works. Therefore, the total change in potential energy is the sum of the individual changes, one term per interaction. And if the system is closed with no non-conservative internal forces, the master relation survives untouched. Total delta U equals negative total delta K. Step back and see the whole chain. Newton's third law collapsed two work integrals into one integral over the relative displacement. Because the force is conservative, that integral depends only on the endpoints, so its negative defines the state quantity, the potential energy of the system. In a closed system, delta U and delta K cancel exactly, and every interaction contributes its own term to the total. Next video, computing them, 3 concrete potential energy functions and the freedom of choosing where zero lives. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.